Welcome back to my channel. This is Darian with Darian the Dev. If y'all with me a couple seconds ago, we had some technical difficulties, so I restarted the stream. But thank you guys for joining. If you're into tech, entrepreneurship, coding, startups, anything like that, make sure you guys like, share, and subscribe. It really helps me stay motivated to put this content out for you guys. And I'm here with La, and we're about to recap the last, the first through the fifth week of our career progression bootcamp. And if you guys don't know, it's basically where as software developers, since we started working professionally, we want to stay on top of our game and just get as good as we can, obviously. And so we put this curriculum together to kind of help us just stay, on track and stay up to speed with our learning of new things and all that good stuff. And we share it every week here with you guys. So here we go. We're about to go ahead and get started. I was having some screen share problems on the last stream, so that was why I had to restart, y'all. So I apologize. I'll go ahead and share my screen now, and we should be good to go, hopefully. So let me go here. In fact, bow. Perfect. Can you see my screen lock? My computer.
Nothing right now.
All right, yeah, it might be a lag.
Right now.
Yep. Can you see my screen lock?
Yep, I can see your screen.
All right, cool. Okay, so we're gonna go ahead and jump into weeks 1 through 5, guys. Like I said, put together some slides, and we're just gonna speak on basically the topics. And this is gonna be really informal, so make sure if you guys have any questions or any comments, go ahead and throw them down in the chat. I'm gonna have the chats up right now so I can actually see as you guys are leaving any comments. So if you have any questions about anything, we can answer those for you. And so here we go. All right, so week 1 was focused on networks mostly. And so pretty high level, La and I both had our own studying that we did on networks. So we had, a bunch of different notes that go really far in depth on all these things. But we're just going to kind of touch on them, our takeaways from them. And again, these are we're reading a lot of networking textbooks. So this is the type of stuff that was actually covered in those textbooks. So if you were, studying computer science or anything like that, this is literally chapter 1 of a networking book is going to more than likely expose you to some of these concepts. So one of the first things is the different types of networks, right? So we've got LAN, which is local area network. We've got WAN, which is wide area network. The internet itself is a network. We have a metropolitan network, and we have personal networks. And the main difference between these, from my understanding, was really just the size of the network. So how many people you plan to have actually on the network at any given time. And then also what you're trying to do. So over what distance are you trying to send information to another computer or someone else on that network? So depending on what it is you're trying to do, there's a different type of network that would probably best fit your needs. So there's different types. I'm pretty sure that, what most of us are using, probably a LAN, WAN, or a personal in terms of here inside our homes and things like that. There's also other ones like continent and countries, but for the most part, these are the really popular ones. And then with protocols, obviously each network is going to have a different way of transmitting data back and forth. And so those rules, or that set of rules, is called a protocol on a network. And this is not the only 4 types of protocols the network has, but it's the most important for you or us as software developers. HTTP, which I'm sure most of you have worked with, probably if you're here on the stream or you've at least heard of it. You've seen it in your browser. A lot of URLs have HTTP or HTTPS, so you guys have probably seen that a lot before. hypertext transfer protocol. We've got TCP, which is the transmission control protocol. You got FTP, which is file transfer protocol, and then you've got UDP, which I might have forgot what UDP actually stands for. Unified
Data protocol.
Unified data. Unified data.
Unified data. Hold on.
All right, we're gonna double check. We're gonna double check just to just to confirm.
User datagram protocol.
Say it one more time.
User datagram protocol.
User datagram protocol. This is probably a great example of what we're doing right now, actually. So if you guys are watching this live stream, I'm sure that we're using some sort of like UDP or constant data transmission protocol, which is basically what that is, that we can continuously send streams of data to another client on the network. So, yeah, these are high-level concepts. These are really important to any network. Obviously, there's a ton that you can go deeper in on these things, but I think that it was important for us to understand kind of where networks fall into play for us as developers, and how our devices actually send data to one another. And this boils down, like, a lot of things fall under the umbrella of networks. So our IP addresses and like when we send data back and forth, the headers on our packets are all very specifically related to the network that we're on. So these are concepts that anybody who is just getting into software development, coding, transitioning into tech, I think that it would be wise and a really big advantage if you took some time to kind of just explore networks and how they work a little bit. You want to piggyback on anything, Lau?
No, I think that was pretty much cool. I think that's pretty much what we were trying to get. Just like you just said, just to recap a little understanding of the network and just getting a basic understanding of what we were doing. We were using our basic HTTP protocols or UDP stuff like that. So I think we pretty much capped it.
All right, cool. So we'll move on to week 2, and we focused on databases in week 2. So let's go ahead and see what we have here. All right. So you want to talk about this one a lot? Or, I also have the slides too, so let me know if you need to see anything, if you want to see your notes or anything like that.
My screen's slower than yours, so I'm not exactly up. I'm coming now. We're coming to.
On the stream. Okay. Sorry.
Yeah.
Got you.
No.
Yeah. So.
All right. So I'm where you are.
Okay.
So pretty much I think week 2 was just pretty much an orientation to databases. I think you did a lot more detail discussion about this. We pretty much dove in to understand that SQL, which is a query language, and it is composed of these 3 types of languages: DDL, DML, DCL, and they all have specific purposes to sort of comprise and make the query language what it was. We talked about schemas, how that every database system has a schema that allows you to understand how the tables are set up and the relationships between them. We talked about relational databases. Pretty much that's the primary way the databases are set up. Relational, how one type of data relates to another. There are definitely other types of databases, but primarily this is the way that's, well, I guess what you say in the past, I would think today there's a lot of different other options, so I wouldn't say that, I would say because of legacy that there probably is more relational databases, but I wouldn't say that that's the primary way people think today. I wouldn't say that. And then normalization just talks about, I guess it's more in line with relational databases, just making sure that all one of the big things with relational databases, aside from the connections, is making sure that there's no redundancy in data, making sure that everything's only there one time. And that's pretty much something that's different than these new ways of being able to formulate databases now versus, using relational. So to me, that was pretty much my summation of it. Like I said, you went more detailed into what the DDL was, what the DML was, and all that stuff.
Yeah. That's really good because so I probably should have mentioned on the previous slide, instead of just saying databases, that we were doing SQL. So this is all very SQL specific. Obviously, a lot of databases are based on SQL. They have their own flavors and rules. But for the most part, the things you see here, some of these acronyms, so DDL, data definition language, DML, data manipulation language, and DCL, data control language. All those things are baked into SQL. So it's multiple languages technically that are baked into the SQL language itself, but they basically give us different access to doing different things within SQL. So each one specifically has things that it's used for. So that is definitely a good. These three things. Again, these aren't the only three languages that make up SQL. I think there's maybe like 2 or 3 more that aren't here, but these are the real primary ones that if you're just a software developer, you'll be working with these more than likely. But I think that anybody who's getting into databases or just starting to kind of get familiar with SQL, I think these are really good topics to start familiarizing yourself with. This is really good kind of database jargon to warm up your learning with. So I think that was really good. So week 3, talking languages. Okay, yeah. So I think this one was from your notes too. So this is different. There's a couple different types of language. I know we're probably still coming up. So I'm gonna let La speak on this, but basically, I'm gonna let you speak on this one. I'm actually, yeah.
Let me just wait till it comes up and it gives us a little more to see.
Yep.
Yeah, so this pretty much was at this part I was looking at the beginning of like Java. So anytime I guess you learn some of these I guess you call them lower level languages, Java, C#, C++. They pretty much go into why they were created, how they were created, and what the purposes and where they rank sort of at as it relates to languages. And so this is pretty much talks. I thought this was interesting because it spoke to how languages were sort of created and the purpose behind creating them. So it started out with the different types of machine languages. You have your assembly language, and that's pretty much your basic ones and zeros, and that's just the absolute lowest level there is, and it talks to the computer, the hardware directly with your ones and your zeros. I'm sorry, I think that's the machine language. Then you get to the assembly language, and the assembly language is a little bit of combination of both. It's still ones and zeros, but it has a little bit of like
there's numbers in there, right? Or not numbers, letters, right? And it's all memory allocation.
No, that's where the assembly language part is where they used to have like your basic things like your go, your run, just your little languages like that, but it was still combined with your ones and zeros. It was still close to your assembly language.
Okay.
When you get to your high level language is where we're at, where you're with Java and C# and C++. And that language is pretty much created for developers to be able to create programs to work with people so that those programs can now work with the computer. Whereas you look at the machine language, that was pretty much created to help the machine work with different other parts of the machine, have the hardware communicate with, I don't know, the memory or something like that. Whereas when you get further along, assembly language is designed to make it easier for people to work in that, and for people to work with machine language. But it was really difficult to work with ones and zeros, so give little things like go and run and things like that, and made it a little bit easier for people to work with. When we got to the high level languages, it was now more how do we get programming, how do we develop software where the average person to use software, that software now can communicate with the computer itself. And that's where the high language like Java and C# came from, and that's the purpose of those languages. They all have different reasons why they were created to do certain things, but in general, as being a high level language, the purpose of it was that. When we get to our next level languages like our Ruby, our Python, our JavaScript, where we're talking about just straight scripts, that's when you get to your interpreters. And what interpreters do is they sit on top of your high language and they sort of almost interpret the JavaScript down to your Java, so it's just reading it right back to you. Where you have your high level language that compile it into that bytecode, your script languages don't even get that far. It stays at the top. So it's almost like, my script language can communicate very well with Java. Java understands all the things that I do. I don't have to break it down to that basic level, and that's why it comes out really quickly. That's why I don't have to typecast it. That's why I don't have to do certain things, because you're not really processing my language. You're just reading it right back to me right away. Versus with Java and C#, and that's why that's a little bit more faster, because they have mechanisms that once they start to break down some of that bytecode, they cache it. So the next time they go to that bytecode, it's a lot faster and it's a lot more secure. So I just thought that was pretty interesting when we were learning about the languages, why they're there, and the purposes of them as we were moving along. So that was pretty much this section.
That is interesting because I know assembly is if anybody wants to get into like IoT or like programming hardware, whether I know I saw one of my favorite YouTubers, Devin Crawford, did a video where he was programming some LED lights that he bought off Amazon, but he had to connect the electrical strips to some circuit board, and then he had to write some assembly code to be able to program the LED lights themselves. So I think that's interesting because it's still relevant. It's not something that you'll see on a daily basis, or really probably ever as a software developer, seeing assembly code, but it is still very relevant if you want to get into IoT and doing hardware programming. It's very important to know that. So that was a really good explainer and definition of each one and how they're a little different. So this one was me, week 4. We talked about Azure functions, so now we're getting into serverless programming or cloud development. And basically, I went over the highlighted points. So Azure function is basically made up of 2 things, just an event trigger and code. So the code looks pretty standard like any other function. Let me move this over here. Yeah. So the code itself looks pretty similar to any function that you guys have probably seen in any other language. And again, Azure is Microsoft products, obviously, but this is very flexible for a lot of different languages. You can use JavaScript, you can use C#, Java. There's a lot of different languages that are compatible with Azure functions in Azure. But the code is just a basic function, but you will write it, in a specific way that it accepts an event trigger. And so the Azure function itself doesn't run unless it's triggered by one of these events. And so these are some of the popular types of events that can trigger your function to run. So a HTTP trigger, meaning that if we make a call to a certain HTTP URL, that it'll run our Azure function. Could be a timer, and this is useful for things like jobs. So if I needed to look at the content of a folder that was sitting on a desktop of a certain device or something like that, and I needed to check that folder for updates every, let's say, 5 minutes or something like that, I could write a function that would check that folder and then use a timer trigger to actually cause it to happen and be triggered on a recurring basis based on that timer. So we've got blob storage, which is don't get me totally don't take me literally here, but blob storage is similar to a cloud database. I'm not 100% sure of the difference between them because it's not, I wouldn't necessarily call it a cloud database because I don't believe that's the same purpose, but it serves a very similar storage purpose as a cloud database would. So between Cosmos DB and blob storage, they're very, very similar. I'm just still trying to kind of understand the nuances of each, but again, you could think of it as, something like a database. It's going to hold information that you send it to it. So we can run our Azure function anytime something is inserted into blob storage or anytime there's a new record added to blob storage. Same thing with Cosmos DB, which is just a cloud database. And anytime there's a new record or a change to the database, we can trigger our function to run, and also queue messages. So we can send messages into queues, and we can cause things to happen based on what the message says. So the queue can be triggered from a different Azure function, the queue message, and then once that queue message has a certain value or actually gets called, then we can then run our Azure function. So there's a lot of different ways that you can actually trigger Azure function, which is really cool. And then separately from that, they have different levels of authorization. So obviously we wouldn't just want it so that anybody could call our function, or that anybody has access to, part of our code base that's up in the cloud somewhere. So Microsoft provides a couple different ways of authorizing your Azure function. So an Azure function in itself could be a singular function, but you could have a function app, which is essentially an API of function apps. So you could just think of it as multiple function apps that all have different triggers, and that entire application is referred to as a function app. So there's two ways that Microsoft allows us to do authorization on these, either Azure Functions or the entire function app itself. So of course we can go anonymous, which is basically just saying, hey, anybody who has access to hit this URL can run our Azure function. So that's pretty much just ad hoc. It's anybody can trigger the function. Then we have function-specific authorization, which generates a secret key for each function. So each time someone makes a call to the URL of the function is going to trigger off of, or whatever is going to trigger the function, anytime someone attempts to trigger that, they need to also have the proper key for that specific function. So I think that's really cool because, like I said, the key is different for every function. So it's almost like impossible to really like I said, someone to have access, to your code or whatever without you expressly giving them the key. And then there's also an admin authorization, and so this is the function app security. So basically, we can authorize the use of the entire function app. So we can either have a function app that has some anonymous functions and some that are protected with a key, or we can just authorize the entire function app with using a admin authorization, which is a secret key that needs to be sent anytime we make a call to any function inside the function app. So you guys can hit this up on Google, go check out Azure function stuff, or just Azure in general, Microsoft Azure, and just play around with this. This is no different than AWS Lambda, I believe it's called. So they also have their own, if you're like an AWS person, they also have their own serverless cloud functions. But again, I think this was a really cool thing to dive into because I was doing this for work at the time, but it's also just really cool to know that, for example, if you have an application that's already completely done and you want to add some additional functionality to your application, but you don't want to kind of go in there and dig into the wires, you can always go and create a function app and add additional functionality for your application over in that function app, which is really cool to me. So yeah, that's Azure Functions. So we'll move on to our final week for this week's recap, which is week 5, C#. So
that's you take it away, right?
Back up again. That's right. So in this week I went over LINQ, which is language integrated something query. I gotta look that up now, because now it's gonna bother me. So all right, so let me look it up real quick. Make sure I'm giving you guys the correct information on this channel. I know y'all are gonna grill me if I don't. So language integrated query. Okay, cool. I know what the N stood for, but it gets left out anyway. Beautiful. So language integrated queries, and I think what was cool about LINQ was the idea that it's a specific way to iterate through any sort of collection of things in C#. So instead of just using a traditional for loop or a for each loop, I know in JavaScript, some people like to use the map function. I know they have loops in JavaScript as well, but I think mapping is probably the more modern way of doing things, like looping through things in JavaScript. But in C#, there's a lot of different data sources that we could be pulling from. So we could have XML, we could have something coming from SQL in our database, we could have a list, we could have a dictionary, we could have an IEnumerable. So there's all these different data types that could hold data that we need to iterate on, and there wasn't a unified way of doing that across all types of data sources, and that's where LINQ comes into play. So it gives you a way to iterate on any sort of collection of items. It literally doesn't matter. It could be generic objects, it could be dynamic objects, it could be anything, and LINQ allows you to basically get and retrieve data in the same way from a SQL query or from a SQL database as you would from, like I said, a list of strings or a dictionary of strings and integers. It's all the same, and it gives you multiple ways of doing it. So we can use like a SQL syntax that looks very similar to it looks very similar to what you would see as you get more comfortable, like writing SQL statements. Link basically almost works the exact same way. It has like selects and wheres and froms and all that stuff, just like SQL. So you can do it that way. And there's also like another like way to query as well that is specific to Link, and it looks very much just like regular C#. So it's really cool that you have the freedom to kind of bounce back and forth and choose how you want to iterate on different objects. So, or different collections of objects. So Link is really cool, definitely worth looking into. If you're a C# developer, C#.NET developer, I would definitely look into Link if you haven't already. Interfaces is really big. So, I'm not going to go too deep on interfaces here, but, interface just declares methods. It doesn't actually give them functionality. So this is really useful for designing your programs, because concrete classes and interfaces kind of go hand in hand, because you'll have a concrete class that inherits the interface and uses it to give the functionality to the methods that are in the interface. So they're different, but they do work hand in hand, because you need a concrete class to actually utilize the interface. But they do have different purposes, and it's very important to know those differences as software developers, the difference between a concrete class and interfaces. Lambdas are also very useful. They're basically just anonymous functions, but they're very cool, very interesting ways of being able to make your code a lot cleaner and a lot more readable for other people. So lambdas can be used in an incredible amount of ways. Like Link uses lambda expressions in their queries. So you'll see, if you guys do research on Link queries, you'll see that they use a lot of lambda expressions in it, but it's all just for readability, basically. And then lastly, a concrete class obviously is a class that is going to have everything explicitly laid out in that class. So whatever functionality, behavior, properties that the object should have is all going to be inside that concrete class. So these are just things that are, obviously very important. This is C#.NET specific, but, I would say concrete classes and interfaces are just important OOP concepts for any language, Java, like any object-oriented language. You're definitely going to want to know or be familiar with those two things. I'm not sure about lambdas as much in Java and other OOP languages. Not sure how prevalent they are. And Link, I know for sure is a C# specific thing, so don't get too hung up on that if you guys are looking to go continue studying from here based on some of the stuff you saw us talking about. That's only for C#.NET, but it is a really useful thing to be aware of and to know about. So let's see, bring us back on the stream. Okay, cool. So yeah, that for the most part, that in a nutshell kind of wraps up the first 5 weeks of our curriculum. We went weeks 1 through 10, so we're gonna come back again next week, and we're gonna do another recap of weeks 6 through 10 to just round everything out before we go into our next like phase, I guess, of the career progression bootcamp. So, Allah, do you have any thoughts or, I guess, recap on this curriculum? Like, I guess back in January, if you think back on us, or really December when we were putting this together, and like what we were trying to get out of it. I guess when you look over these first 10 weeks of the year, I guess what's your takeaway from us going through this curriculum?
I think we had a great start. I think a lot of great foundational information. I think we learned a lot. I think it sort of helped a lot in just the day-to-day work, just starting out.
Yeah.
So, yeah, I thought it was a great start.
Yeah, I think one of the biggest things I noticed is, so La and I work together a lot. We pair program a lot. We've been wanting to live stream it, but we got to figure out a way to make that work so that y'all aren't, just watching us, like be in our zone and not even talking, just, deep in code. But we do a lot of pair programming together, and at least for me, I've noticed that this curriculum has really made troubleshooting a lot more smooth of a process. I think from understanding things down on like the operating system level and on the networking level, which we'll get into as we go next week, guys, and recapping week 6 through 10, when we talk about some of our operating system stuff. But I think that was where I probably noticed the biggest benefit was just being able to kind of troubleshoot or decipher like errors, whether it's database errors, network errors from, trying to make a fetch call, like whatever it is. I think having a better understanding of networks and spending that time, really kind of going through it. Obviously having some long nights on our side projects, but I think that also helped a lot too. So I think just the curriculum in itself was great, but I think us pairing it with projects and working on things, pair programming, also allowed us to really apply like the things that we were reading about. And I think for me, that really helped my troubleshooting process, which I think helped speed up my development process, because I'm not just so much spinning my wheels and taking shots in the dark so much. It's like now you have a much better idea of what the error is trying to tell you. At least for me, that's me.
Mm-hmm. Yeah, I agree.
Yeah. So cool. So yeah, guys, we're gonna wrap this one. We're right just over half an hour. So I hope that y'all got some value out of this one. Like I said, leave us some comments down below. And we'll get back to you guys, and we'll be back here for one more week of recapping. Next weekend, and then we're going to be also probably rolling out next week our plan going forward for this next part of the boot camp. But like I said, y'all, it's coronavirus, so y'all take it easy out there. Stay safe. Like I said, we had to just kind of adjust ourselves to working from home, and just kind of the change in pace with all this craziness, not leaving the house and everything. And so and we're also working on our projects too, so we'll be excited to show you guys a lot of what we've been working on the actual code side too. But I hope y'all have enjoyed this first 10 weeks. We appreciate y'all for being here with us. Lod, thank you for hopping on as always, and we'll catch y'all next week. All right, so we'll see y'all. Peace.